Good morning, students. Now, important theorem, the Gram Schmidt process. For a given basis x1, x2, and so on xp, some vectors are given to you, or which is a basis for a subspace. Now we have to construct an orthogonal basis. Orthogonal basis using the given basis, right, or given linearly independent set for a subspace. Now let the orthogonal basis will be v1 comma v2 and so on vp. And what are v1 v2 and so on vp means you have to by heart this formula. V1 is always equal to x1, v2 is equal to x2 minus x2 dot v1 by v1 dot v1 into v1. v3 is equal to x3 minus x3 dot v1 by v1 dot v1 into v1 minus x3 dot v2 by v2 dot v2 into v2 and so on, right? No need to by heart this last one, right? It's a theorem, important theorem. I'll explain this theorem in the class, right? Physical class. Please copy these notes. And next one is orthonormal basis, right? After getting orthogonal basis, simply normalize it, right? For example, v1 comma v2 is a orthogonal basis. If you want to construct orthonormal basis, simply normalize it. What do you mean by normalization? Simply finding the unit vector in the direction of v1, so unit vector in the direction of v2, that is called orthonormal basis. That means this orthonormal basis is nothing but v1 by norm v1 comma v2 by norm v2, right? This is called orthonormal basis. If it is an orthogonal basis, then this becomes orthonormal basis. That is important, right? Now normalization, or you can say scaling. Okay. Now next one is problems, important concepts. Gram Schmidt process, right? Now one vector space is given to you, and also subspace, and also a basis, right? Now here the important thing is basis for a subspace. That is important. Using that basis we are going to construct orthogonal basis. Okay. Now see here, now w is equal to span of x1 x2, where x1 and x2 are given, right? Now construct orthogonal basis for this one. What is construct orthogonal basis? That is denoted by v1 and v2. We have to find v1 and v2 using these x1 and x2. Here x1 and x2 are 3, 6, 0. x2 is 1, 2, 2. Now see, orthogonal basis for w is v1 comma v2, where v1 is always equal to the first vector x1. Remember, in any problem v1 is always equal to x1. Now we have to calculate v2. v2 is nothing but x2 minus p I am writing, where this one x2 minus x2 dot x1 by x1 dot x1 into x1. See here, this also can be written, this one can be written as p is equal to x2 dot v1 by v1 dot v1 into v1 as per our theorem, right? See here, v2 is equal to x2 minus x2 dot v1 by v1 dot v1 into v1. But what is v1 according to our assumption? First one, x1, right? Now see, don't confuse, no need to confuse with this formula. You can directly write down this one, right? Now what is v2 here? v2 you can write it as v2 is equal to x2 minus what you have to write? Wait, x2 dot v1 by v1 dot v1 into v1. That is the formula. v2 is equal to, now we need to find x2 dot v1, or you can say x2 dot x1, because v1 is equal to x1, no, right? v1 is nothing but x1 here. Okay, now we are finding the inner product, or we can say dot product. The dot product is 15. Next we have to find in the denominator x1 dot x1. This is nothing but v1 dot v1 as per our theorem. v1 dot v1, which is also 45. The inner product of that vector v1 is 45. After getting this one, we have to calculate v2. What is v2? Right? Before going to find v2, first of all, I'm simplifying. I wrote p no there. Now p is equal to x2 dot x1 by x1 dot x1 into x1. I am calculating separately. After getting p, I am calculating v2. v2 is equal to x2 minus p. Right? I am subtracting corresponding elements 1 minus 1, 2 minus 2, 2 minus 0. This is 1. Therefore, v2 is equal to this one. I got v1 directly. What is v1 actually? v1 is always equal to the first vector in the basis x1. That is 3, 6, 0. And again, I got v2. v2 is 0, 0, 2. Therefore, these two vectors, collection of these two vectors forms an orthogonal basis. First of all, I wrote orthogonal set, this one. Now the set v1 and v2, v1 comma v2 is an orthogonal set of non-zero vectors. No, both are non-zero vectors in W, and the dimension of W is what? 2. Right? If W is what? Span of x1 comma x2. How many elements are there? 2 elements. Therefore, dimension is equal to number of elements in the basis. No, that is 2. Now, this is linearly independent and it contains 2 vectors and it is orthogonal. Therefore, it is a basis. We know one theorem is there. No, every orthogonal set is linearly independent. Right? Now, this is an orthogonal set, therefore it is linearly independent and it contains how many vectors? Only 2 vectors, both are non-zero. Therefore, this forms a basis for W. Therefore, the v1 comma v2 is an orthogonal basis for W. How to construct orthogonal basis for a given subspace means we have to calculate v1, v2, v3 and so on. You please remember, try to find by heart these formulas. v1 is always x1, v2 is this one. Don't confuse. In the previous problem I wrote x1 instead of v1. v1 is nothing but x1 only. Right? Now, see, we got orthogonal basis for W. Okay. Now, next, another problem. See, how many vectors are given to you? 3 vectors are given to you for a subspace, right, which is linearly independent. Now, construct an orthogonal basis for W. That is important. How to construct orthogonal basis? Orthogonal basis is equal to how many vectors are there here? 3 vectors. Therefore, you have to find v1, v2 and v3. Right? Now, see here. I wrote the given data. R power 4 is a vector space. W is a subspace of this one. x1, x2, x3 is a linearly independent set, of course. x1, x2, x3. This is the given data. Now, we need to construct orthogonal basis. 3 vectors, therefore, we have to take 3 orthogonal vectors. Right? First one, v1 is always equal to the first vector. What is v2? v2 is nothing but x2 minus x2 dot v1 by v1 dot v1 into v1. In the first problem, I wrote x1 in the place of v1. Okay. Now, next v3. v3 is equal to x3 minus x3 dot v1 by v1 dot v1 into v1 minus x3 dot v2 by v2 dot v2 into v2. Now, we have to calculate v1, v2, v3. Now, what is v1 is nothing but x1, no? As it is. Got it. Now, to get v2, we need to calculate x2 dot v1, no? x2 dot v1 I am calculating. That is an inner product definition. Now, multiplying, I got 3. x2 dot v1 is equal to 3. Next, in denominator, v1 dot v1 is there. v1 dot v1, inner product of v1 and v1. Now, this is the definition I wrote. This is T, no? Right. I got 4. Now, I am calculating this one. v2 is equal to, I wrote the formula once again, x2 minus x2 in dot v1 by v1 dot v1 into v1. There is no dot here. See, x2 is 0, 1, 1 given data minus x2 dot v1 is 3, v1 dot v1 is 4 into v1. v1 is nothing but x1 now, 1, 1, 1. multiplying inside. 0 into 3 1 which is 3 by 4. 1 into 3 by 4 is 3 by 4, 3 by 4, 3 by 4. 0 minus 3 by 4 is 3 by 4, 1 minus 3 by 4 is 1 by 4, 1 minus 3 by 4 is 1 by 4, 1 minus 3 by 4 is 3 by 4. This is nothing but subtraction of two matrices, no? Right. Now V2 is equal to, I got minus 3 by 4, 1 by 4, 1 by 4, 1 by 4. Now we need to find the third vector, right? That is V3. Now to calculate V3, we have to find x3 dot V1, no? x3 dot V1, right? x3 transpose V1. Again, this value is equal to 2. x3 dot V1 is 2. Again, x3 dot V2 also have to calculate. In the formula, there is x3 dot V2, no? That's why that value is equal to 1 by 2. Now, we need to calculate V2 dot V1. V2 dot V1, V2 dot V2 is equal to 12 by 16 means 3 by 4. V2 dot V2. Already we know V1 dot V1. Already calculated, no need to find. Now see here, I wrote this formula. ఇక్కడ చిన్న మిస్టేక్స్ ఉన్నాయని చెప్పి 1 సెకండ్ ఇలా రాస్తున్నాము, సేమ్ థింగ్ యాజ్ ఇట్ ఈస్. రైట్. నౌ see x3, v3 is x3 minus x3 dot v1 by v1 dot v1 into v1 minus x3 dot v2 by v2 dot v2 into v2. Now I am substituting those values. v3 is equal to x3 is 0 0 1 1, x3 dot v1 is 2, right? v1 dot v1 is 4 into v1 is this matrix. Now 2 times cancel, 1 by 2. Now x3 dot v2 is 1 by 2 by v2 dot v2 is 3 by 4 into v2. v2 is minus 3 by 4, 1 by 4, 1 by 4, no? Right. This one as it is. Now multiplying inside, 1 by 2 into 1 is 1 by 2, 1 by 2 into 1 is 1 by 2, 1 by 2, 1 by 2. Now here I am simplifying this one, 1 by 2 into reverse, 4 by 3, 2 2s are 2 by 3, right? Now 2 by 3 we are multiplying inside, see, 0 0 1 1, this one as second matrix is this one, minus third one, 2 by 3 we are multiplying inside, 2 by 3 into minus 3 by 4, 2 by 3 into 2 by 4, 2 by 3 into 1 by 4, 2 by 3 into 1 by 4. On simplification, I am getting this result, right? Again on simplification, V3 is equal to 0 minus 2 by 3, 1 by 3, 1 by 3. I know V1, V2 and V3. The orthogonal basis for W is equal to V1, V2, V3. Therefore, this is an orthogonal basis. Sir, how can you say that this is an orthogonal set? Means we can calculate what is orthogonal set. Each pair of vectors is orthogonal. When do you say that a pair of vectors are orthogonal? If their dot product is 0. Now if you calculate v1 dot v2, that inner product is 0. v2 dot v3, that inner product is 0. v3 dot v1 is also 0. Therefore this is an orthogonal set and it is a basis. Therefore this is called orthogonal basis for W. Suppose if you want to construct orthonormal basis, after getting this result, what we have to calculate? Simply v1 by norm v1, v2 by norm v2, v3 by norm v3. That set is called orthonormal basis. Okay, that means we have to find unit vector of v1 in the direction of v1, right? Unit vector in the direction of v2, unit vector in the direction of v3. That means we have to normalize each vector in this basis. That set is called orthonormal basis. Orthonormal basis is equal to, what you will get, braces v1 by norm v1, v2 by norm v2, v3 by norm v3. Okay, right.